5:30C. It's my job now to finish up this interesting morning and diverse morning session with a finishing topic. And okay, I try to make it as short as possible, but I hope I can get your attention until lunchtime. Yeah, the topic is anti-soiling. I don't think I need to convince anybody here in this room about the nice aesthetics of the leather article. Yeah, everybody knows leather has to undergo throughout its lifespan a long, continuous development, and yeah, color shades are becoming lighter, and that is a thing which is not something from the aesthetics, also from the car manufacturer. They like to use lighter colors because from a psychological aspect, if you sit in a car and if you have dark leather on your seat and the dashboard, door panels, yeah, it just gets closer, and they would like to have a light interior. But of course, a light interior doesn't look only nice, it also has disadvantages, and it comes to anti-soiling immediately, and yeah, we have to look for some finishing technologies in order to improve the anti-soiling performance. On the other hand, it is very important to maintain the aesthetics of leather. And that's the reason, because since several years we are working, five years, we focus our R&D on the development of an anti-soiling technology, and I would like to share our findings and our results here with you. I've put my presentation, I've structured it a little bit. I want to talk about some basic and definitions and about theory, what we have basically learned, and yeah, differentiation about some performance characteristic testing, very important if you talk about a result, yeah, that you're not comparing apple and oranges again, and chemistry, anti-soiling technology, what we have developed, and then I come to some results and conclusions. Talking about basics and definitions, two words are coming up very often if you go to someone and talking about anti-soiling. The first thing is nanotechnology. I was asked very often about tanners, do you also sell nanotechnology? And I'm asking them, you know what it is, nanotechnology? No, that's the reason because I'm asking you. And then they said, yes, that's on one thing something great, but on the other thing it's something very, very small, and that's just called nanotechnologies. And just to get an idea about the dimensions, everybody talks about nano, yeah? That is a dimension of one football, 1 nanometer, and 1 millimeter is the Earth. It's a millimeter, not a meter, you know. That is the dimension everybody talks about, nanotechnology, so that's a molecular dimension, yeah? And actually there are different types of nanotechnologies, and simple colors or acrylic dispersions, which are in this range, they are also nanoparticles. Yeah, so that's nothing of rocket science. Yeah, and then I'm asking the tanner, did you bought already one dispersion from us? Then he said, yes, that's the reason, because we are selling nanotechnology. Yeah, so nanotechnology just means very, very, very small dimensions, nothing else. And this nano, it's really misused in the meantime, and it means some type of rocket science or so on. That's not the case. The other thing which very often comes up in these discussions is lotus effect, and even there a lot of nonsense is around the meaning of lotus effect, and everything suddenly has a lotus effect, and therefore I would like to explain it a little bit what it is. It's basically discovered very recently in the 90s, and it was in Germany at the university in Bonn. There was a professor who was watering the flowers, and he found out some flowers turned to get dirty leaves, and some flowers, the leaves were remaining still green. And he was investigating this, I think it was in '93, and he investigated this first at this lotus flower, and he found out that the lotus flower has a very special surface, because you see here, that's in a molecular range. It has little pins, and on top of those pins there are still little pins, you see here. And if a droplet or some dirt is on the leaf, yeah, it sits on these pins like on a nail, wooden nail, yeah. And if a water drop then runs over this leaf, it takes all the soil with it. Yeah? And that is a self-cleaning effect. And that's very interesting, and there are a lot of applications who try to imitate this effect. But if you ask me, and I come to this later, if you have such an effect on the surface of a leather, yeah, and if you do some kind of abrasion tests, then with this leather, this will never survive. So from that point of view, if someone tells you, I can make you a leather surface with a lotus effect for an automotive seat, I don't believe. Yeah, this is not surviving those conditions. It is fine on a leaf, and it's maybe fine on some walls or so, yeah, but not on a leather which is used as an upholstery or as a shoe. So these are the two topics, nano and lotus effect, which are very often in this discussion. Good. There are a lot of requirements everybody knows a finishing leather has to fulfill. I will not go in detail with this. There are certain clusters and certain properties behind each cluster, and the problem, a general problem, very often is that if you want to optimize one of those properties, yeah, basically you sacrifice others. Yeah, it's a simple example. For example, if you have the binder elasticity, we can make a binder low, the elasticity low, we can make it high, that's based on the chemistry. So for one property, for the print retention, it would be good if it is low. Yeah? And for a flex, for example, it's the opposite. Yeah? So the challenge basically for the chemistry is we have to look always for some kind of a compromise, and for the application or for the leather chemists, they have to formulate around those weaknesses in order to maximize these properties. That's always the case. Why do I bring this up? Now we are talking about anti-soiling. What is anti-soiling? It comes up in the last 5-7 years. Yeah, it's a topic. It's basically a job for the chemical industry to develop something. And I want to tell you, this is not a property like color strength or light fastness. It's again something very, very complex. That's what we had to learn. Yeah, it's like an additional cluster, and this additional cluster is not a property which is separate. It also is a cluster which has some conflicts with certain properties. For example, recoatability. That's the easiest thing what you can say. If you have a leather, everybody wants to have the leather surface recoatable. Yeah, that's especially in the automotive industry. Yeah, if they have to bring it back into production and to put it, because the color was not perfect, yeah. So you need to have a certain recoatability. On the other hand, as better your recoatability is, that is here, yeah, as worse is the anti-soiling performance. Yeah. So therefore, you are, again, if you want to optimize your leather for a good anti-soiling performance, you automatically have some problems. Yeah, which also everybody wants to have. So it's again this compromise what we have to work out. Anti-soiling is not an easy thing. It's pretty complex, and I would like to explain to you a little bit how we have structured this based on all those findings what we have. Basically, it's a surface effect, yes, of our leather, and you have to look at two things. And the morphology, basically this is the physics of the surface, and the substance itself, that's the chemistry. Yeah. If you look at the physics, you have morphological effects in a macro scale. Yeah, like for example, a matting technology that is 10-15 microns thickness of a matting agent. Yeah, but you also need to look at much smaller morphological effects like holes, like little holes in a scale of 10 to 1 micron, 10 nanometers to 1 micron. And in the chemistry, there are two major things which you need to think about if you talk about anti-soiling. That is the hydrophobicity and the oleophobicity. I come to this later. And all these effects are basically a result of the chemistry, but not only of the chemistry, also of process steps like embossing. How do you emboss? You can have the same leather with the same coating. If you have different type of embossings, you get completely different results in anti-soiling. And also the drying technology is playing a very, very important role. How the binder, what you put on the leather is drying. Is it drying very fast? What temperature? There's a different result in the anti-soiling performance of your article. Talking about the, the physics, about the physics first. Here you see a normal photograph taken from an automotive leather conventional top coat, yeah, what we were selling to several customers. And you see here that's a dimension 200 micron, and here that is 5 micron. You see there are little holes in the surface which you can't see by your eyes, but if you go in higher magnification, you see. And those holes, if some dirt or so goes inside of those holes, it's clearly, it's very difficult to get out. Yeah? Such a surface tends to soil. So you can optimize your formulation, yeah? You can come up with surfaces with much less holes, and you can also come up to surfaces where you really get a film, which is where these holes in macroscopic scale you avoid. And if you have a surface like this, and that is one of those results of our PTFE copolymer I explain later, it's, yes, it basically seals the surface of soil, yeah. However, and then you have less penetration of soil, and it can much easier cleaned away. Yeah, it's logical. However, if you soil a leather, yeah, the soil can't get in anymore, and it sits on the surface, and from the visual aspect, it gets dirtier. Yeah, because you have a monolayer of dirt on the surface. You can clean it away very easy, but if you have two seats, yeah, and one seat is protected with something like this, there are certain tests where this anti-soiling protected leather appears to become easier dirty, which is not the case. It's just a visual effect. And I will explain it to you with some facts later on. Microscale surface, I just mentioned this nano effect on the leather surface. From my perspective, forget about. Yeah, we will not get an automotive leather with a sustainable lotus surface. For me, that is, and this self-cleaning effect, for me, that is not possible. Coming to the chemistry, the other part. Here, we're looking for special additives. However, during our development time, we found out there is a lot what you can do right, and a lot what you can do wrong, which has nothing to do with our special developed additives for anti-soiling properties. For example, we found out that acrylic chemistry works out much in favor of anti-soiling compared to PU chemistry. That was the second picture what we had with much less holes on the surface was an acrylic top coat, and with a lot of holes that was a PU-based top coat. The concentration of emulsifier is important. The special silicone which you use, yeah, is very important. Matting agents are playing a very, very important role. Everybody can imagine if you have a porous silicate as a matting agent, yeah, and it sucks some ink or whatever, you never get this out. You never get it out. And if you have a silicate which is filled with a polymer, you can't, no dirt can get inside. So depending what kind of matting particles are in your base, in your finishing coat, you get completely different results. Cross-linking is very important, not only for the performance, also for the anti-soiling effect. And then there are certain special additives which can improve the anti-soiling performance and which also can have negative effects on this. As a general thing, there is not one single additive where you can say if you add this in a top coat formulation you get a nice performance. Yeah. On the other hand, there are a lot of additives. If you put them in, they they destroy your whole effect regardless what you do there. Yeah. So there are some really wrong single additives which you are not allowed to use, and there are certain single additives which moves up the anti-soiling performance, but they are not the only bringer. Talking about oleophobicity and hydrophobicity, maybe you remember I mentioned this is a very important thing for anti-soiling performance. And if you put this in a diagram, yeah, like here, there are certain chemicals like paraphenes. They are very good for hydrophobicity, but they are very poor in terms of oleophobicity. Yeah? silicons. If you add up the silicon in your finishing top coat, yes, it's a good result. But the best chemistry is Teflon PTFE, polytetrafluoroethane. Yeah, that is the best chemistry, which has which has an hydrophobic as well as an oleophobic characteristics. So now coming to some differentiation of performance characteristics, what we also learned, and then testing. Testing is not so easy. Abrasion is much easier, or flex is much easier to test than anti-soiling. And therefore a lot of tests are right now known, and it's very difficult to compare results. What we have learned, we have to differentiate between anti-staining and we call it anti-soiling. That is a differentiation what we have to do. And then, of course, that is the performance, that the leather doesn't become dirty, but also the cleanability is something which is very important, and which also is something, if you want to optimize cleanability, you have to do something else. So staining, we say, is something, if something is accidentally or occasionally contaminating the leather, yeah, like wine, coffee, yeah, if something drops out, the coffee has to land somewhere, and it lands on the sofa, and the sofa becomes dirty, yeah. And soiling is something which is a constant exposure, yeah. If you get in and out of the car hundreds of times, yeah, and your jeans goes over the seat, yeah, then the seat turns to become a little bit dirtier, and after several months you see this. But that's a completely different thing, staining and soiling. Yeah? And if you have a leather which is good against staining, it doesn't need to be good for soiling, and the other way around. Then cleanability is also something which is tested and seen for example, by the car manufacturers. But cleanability could be also, can you clean it one time and then it's fine? Or is it also long-lasting cleanability, yeah? That you can clean it 3, 4, 5, 6 times. If you have an additive in your finishing system and you clean this additive away, the same what happens with textiles. If you have it 5 or 6 times in the washing machine, yeah, this initial effect is gone. Yeah, if this is the same with leather, if you have some additives in the finishing cone and you clean those additives away, then you don't have a long-lasting cleanability. And if I buy a sofa, I want to clean it 3 or 4 or 5 or 6 times. Yeah? And that is something which is also which needs to be considered, and which is not in any specification currently covered. So coming to staining, yeah, it's we have then defined some kind of internal specs. Yeah? There are no specs available to test really staining. Toyota is doing a little bit, the Japanese, they have this marker, and then they have coffee and different types of stains. We apply it, then we dry it overnight, and then next morning we take a normal cleaning agent, which is commercially available, and clean it away, and then we see here after cleaning, then we compare this. That's a simple test. Soiling. A lot of tests are already available. I don't know if you're aware about the Martindale tester. That is a standard tester. You place a sample, you have a Dean clause, a Dean dirt basically, what you have on a stamp, and the stamps goes over this leather so many cycles with a certain pressure, and then you can then you soil the leather, and then afterwards you put a cleaning cloth in, and then you do the same, and then you clean it again, and then you measure just the color change compared to before. That is the test. What it's done sounds pretty simple and pretty easy. However, there are also a lot of different test procedures, and you have to be careful to compare any data. I want to explain it briefly. This is a so-called BDA test. That's from the German automotive group, the BMWs. They have put together this as a test. There are 2 different cloths, the EMPA. These are standard cloths coming out of a company from Switzerland, where it's basically a Dean dirt. You can buy this, and that is by Dean. It's always different, but here you see already it's completely different. That is a cotton jeans and that is a polyester, and this gives already, if you have the EMPA 104 and the EMPA 128, you come to completely different results. So if someone does a test, ask what kind of EMPA you have taken. And then the pilling holder, that is this holder where you put this glove on. There are also two different methods available. Some OEMs are using the pilling holder of 140 millimeter diameter, and some OEMs using 38 millimeters. And if you succeed in this test, it doesn't mean that you succeed with this test. So you have to ask, when they say, yes, we have used the EMPA 128, yes, we have done a Martindale tester, you also have to ask what kind of pilling holder you have taken, yeah? Because these are completely different results what you achieve. Then there is a third test from automotive, that is from the Ford group. And Ford, Land Rover was there. Land Rover is now an Indian company, but I guess they have taken the test with them. They have a dye-ingress test. That is a different gloss. They have a different soiling gloss, and again, it's an indigo dye, and it's again a completely different type of soil that you apply on the leather. So if you are good in this test, that doesn't mean you are good in this EMPA test, and the other way around. So my message basically is, it's very complex. We had to learn this. Yeah, we were with one customer. They were very happy with our formulation, and we went to another customer, and he says, "Sorry, I can't match my requirements." And therefore, we found out there are so many different specifications out, and you have no universal finishing which covers all those specifications. You have to ask the customer what really is your requirement and specification. And then, of course, we can now, based on our experience, design the best formulation to get this target. Yeah, that's a dye-ingress test again. So much about testing, so differentiation and some basic definitions. Now I come to our chemical answers, on our products, what we have developed. And there is as I said, a wide variety of potential contaminants, and as I said, with the oleophobicity and hydrophobicity, the best product, and you have it also in textile, is a TFE, PTFE basically, a tetrafluorethane-based product for anti-soiling properties, what you have to incorporate in your finishing system. Yeah? Why PTFE? As I said already, that is the only chemical. That's the only chemical which is hydrophobic and oleophobic together. Yeah, that everybody know it from a Teflon pen. Yeah, that is the best surface protection if you really want to have an anti-soiling or not an adhesion on this surface. It's thermostable, it is inert against UV, and it has extremely low surface energy and low friction, so it's a lot of nice properties. And now we have to incorporate this in the chemistry, and there are two types of two possibilities how to incorporate this. This is a polymer, basically an acrylic, for example, and you can make side chains on polytetrafluoroethene. That is the called polymer structure. And this polymer has a lot of advantages, because these side chains, if you temper your leather, the surface, they are sticking up, and then you have something like this lotus effect, something like, they are sticking up, and then they have a perfect dirt repellency, but it's initial. And if you clean it very often, you can imagine these little sticks, they are not sticking up as it was in the beginning. And there is another type of chemistry what we have developed, that is where the PTFE is built into the polymer, in the backbone of the polymer. Yeah, this gives also a good dirt repellency, not as good as this one. However, this is a perfect and the most durable cleanability what we have seen. That is the advantages of this technology. So depending what you would like to have. you can choose either one of those systems. Coming to the first one, to this COM structure, yeah. Here this is used as an additive in a special topcoat. It's cross-linkable a little bit, but not like a binder, so it's not, the durability is limited. Yeah, it's not permanent. We will never say this. It gives in the beginning an outstanding dirt repellency and an outstanding initial cleanability. So for the OEMs, they all like it, great, 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 but they only tested it one time. Yeah, if you do it on a continuous base, yeah, this will not give you a long-lasting protection. And you have to be very careful with those chemicals. I don't know if you're aware about the PFOS and PFOS, perfluorooctanosulfonate, and the octanoic acid. These are chemicals which are also in this REACH, on the REACH list, on the high HVC, or what is it called? Very toxic, and on this list on REACH, yeah. And we have to make sure that your chemicals are not having those monomers, again, these side chains. And this is basically, we have to make it clear, and here are some test results from the BLC, which basically show that the products what we have no detectant on those PFOS and PFOA. Here you see, with and without, with our X-Shield L, with our comp structured product, it's amazing. It's amazing after here, that's a normal top coat, yeah, it gets dark, and you can clean it away even if you have a good top coat formulation, but it's amazing if you add such a product, yeah, it doesn't get dirty anymore. It's really good, and the little bit which is there, basically 100% gets off. Coming to this other chemistry, what we have developed, that is the X-Shield G, we sell it, and M is the matting technology. Here we have incorporated the PTFE inside. It has several other advantages. It's basically the anti-soiling additive is a binder itself, which means we can cross-link it with an isocyanate. It's film forming. You can use it as a normal binder with a pigment together, and afterwards it's fixed, and it has a long-lasting abrasion resistance. Looking at the chemistry, one chart, we had tried to maximize, okay, we wanted to maximize the amount of Teflon inside of the polymer. This type of chemistry is available already several years ago, but only in organic systems. Yeah, you can spray it in an organic solvent, yeah, but that is not something which is allowed in the automotive industry. So therefore, we wanted to develop something which is aqueous, dispersible, and therefore we had to add certain functional groups for pigment dispersibility, for dispersion stability in water. We had to look for some functional groups for film formation and transparency, as well as cross-linking, and we have maximized the amount of PTFE inside of this polymer in order to maximize this anti-soiling effect. And then the product now is added as a normal binder together with a cross-linker, generally the isocyanate. You apply it on the surface, and then you cross-link during drying, and then it is fixed underneath and together with the leather surface. So these PTFE groups, they are permanently in, and they, even by cleaning, it's long-lasting, you can't get them out anymore. So that is the most long-lasting protection for anti-soiling, what we can found and what we can offer so far. And that's a very unique chemistry, and yeah, we are starting to promote this in the industry since 1 year. Here are some results for cleanability. Yeah, if you see, let's see. Yeah, the gray one is a conventional system. Yeah, that means 5 to 0. 0 is very dirty, and 5 basically is in the beginning, before doing this anti-soiling test. So you see a conventional top coat, that's what I said in the beginning, doesn't seem to become as dirty as our PTFE layer got. And the reason for us is because the dirt sits more on the surface, so it appears to be a little bit more dirty, because after cleaning you can come to a better result than with a normal top coat. Yeah? So if you do this then not only one cycle, unfortunately in the current automotive specs there is only one cycle that is the specification. Yeah? And if we tell them, hey, do it two, 3, 4 times, they say, no, no, that's not our spec. And so they are, I guess, maybe in a few years, they also look at this. But if you do a second, and if you do a third, and if you do even a 4th cycle, here, you see, you come up, you see the difference. Yeah, the normal system, the gray one, from cycle to cycle, it becomes more and more dirty. And after cleaning, you get less and less cleaned material. And with the PTFE binder, here with this X-shield key, you see you can clean away basically always the same. And even after the second and the third cycle, you are already better in soiling performance. Yeah, that is the advantage of this technology. So if you have a furniture, if you want to have a furniture which is long-lasting in terms of cleanability, this is a very good choice. Also, if you have, we did some pre-treatment, if you do some pre-treatment in order to simulate some usage, yeah, if you have some additives in the surface, or if you have these pores or so, yeah, you also get the same result if after a pre-treatment hydrolysis and just cycles with the clean gloves, yeah, to simulate some usage. You also are with the PTFE type of surface. You can have a much better surface after cleaning, and also the soiling property is not as bad anymore. So these are the 2 types of products what we are offering. This is on one hand this X-shield with a comb structure. You see it doesn't soil at all in the beginning. It looks like, yeah, it really gives a perfect protection, but it is not long lasting. Yeah, this effect goes away after 3, 4, 5, 6 cycles. It becomes less and less and less. If you want to have a long-lasting protection and a good cleanability, then this permanent technology where the PTFE is built in the polymer, and the polymer is functioned like a binder and can be cross-linked and permanently fixed to the surface, then this is the best technology what we can offer in this case. But as I said in the beginning, these are only 2 chemicals which improve the effect, and you also have to be very, very careful what kind of additional chemicals do you still have in your formulation, yeah? And also what kind of parameters you want to have. For example, the gloss level. Yeah, if you see the impact on anti-soiling performance, in this direction in bad, and in this direction it's improving. As duller you want to have your leather, as poorer is your anti-soiling performance. And there are some I mean, if you have a light leather, a light beige tone, yeah, and then the automotive people, they say, but I have to have a gloss level of 1.2. You can't see the difference on a light leather between 1.2 and 2.0, for example. But it's night and day in the anti-soiling performance. So for what reason you want to have this 1.2? Because just it's a parameter which is taken over from a dark leather, yeah? Some stupid requirements are around there. You have to teach the people, and it's very difficult to change the minds there. Yeah? So gloss level is playing a very, very important role in order to optimize your anti-soiling performance. Try to be as glossy as possible, yeah, from your visual aspects. The same as recoatability. If you want to have a high recoatability, of course, I mean, the leather is stupid. It can't distinguish between dirt and recoat. Yeah? So if you want to have a recoatability, then obviously you get a poor anti-soiling performance. Yeah? Anti-squeak is also something. Yeah? If you have an excellent anti-squeak, yeah, it's also not so good for anti-soiling and flex performance also. So, as you know, there are a lot of other additives what you formulate in your top coats and in your base coats in order to get those parameters right, but they all have an impact on your anti-soiling performance. It's not that you can put one additive in and then you get a good result. So it's a result of everything, and that's what we had to learn, and that's what we have to teach customers, and especially even the OEMs at the end. Yeah, they can't have everything. Yeah, they need to decide what is the most important criterion they would like to have. Yeah, as a summary, there are two main conclusions what we learned. Yeah, it's anti-soiling is you need to really differentiate if you want to have a good anti-staining, yeah, for coffee and things like this, or if you want to have a good anti-soiling performance, that is something different, or if you want to have a good cleanability. Customer needs to tell us what he wants to have, and then we have some kind of a chemical solution in order to optimize this effect, but that means not that it is perfect in the other one. And yeah, we have these two products. We have also some other products, acrylics, yeah, which are good for certain tests. And these products are very good for this anti-staining, yeah, with the coffee. We have now some customers, some important brands in the furniture industry who have done and who have studied this coffee test, especially. Coffee with milk is the toughest thing. Yeah. Basically, if you are good in coffee with milk, most of the other stainings are also perfect. Yeah, so that is really a good test, and I mean, everybody drinks at home at the sofa coffee. Yeah, so it's easy that things like this happen. And here, this X-Shield technology with a PTFE incorporated in this backbone has shown the best results. Yeah, this is again just a summary that depending on what kind of performance you have to adjust your formulation. Yes, we have the certain silicones what you have to add. We have where's the crosslinker? Okay, it's not in here, but you have to add a crosslinker also and binders. But you see, depending on what kind of requirement the customer has, we come up with completely different formulations in our anti-soiling portfolio. As a summary, this is a technology where we have special functional products, yeah, which really provide an additional effect, which brings value to the leather. If you have a long-lasting cleanability, I mean, that is a value for furniture or something else. What we can optimize with this technology, and yeah, it's an extra value. We have also made a trademark on this, and we hope in the meantime that we can convince customers that this is really an extra value, that maybe this X-Shield protection then also could be used in the industry as something which it costs. It is additional cost and it's additional value. Yeah, and but I hope it's additional value for the meaning of leather. Yeah, and that is something which I think is pretty important. Thank you.